Hello. In this video, we will go over some examples involving parallel lines and transversals. Some terminology are described on the left. For examples with parallel lines cut by a transversal, corresponding angles are equal. Alternate interior angles and alternate exterior angles are congruent as well for parallel lines cut by a transversal as well. In this example, we are given that L1 and L2 are parallel lines, and these lines are cut by a transversal T. So we can use some of the postulates on the left to answer some questions. For example, the measure of angle 2 is congruent to the measure of angle 7 since they are alternate exterior angles. So the measure of angle 2 is equal to 40 degrees. Let's fill them in on the diagram too. Measure of angle 3 is congruent to measure of angle 2 since they are vertical angles. Also, measure of angle 3 is corresponding angles to angle 7, which is 40 degrees. Let's fill in that in our diagram too. Angle 3 and angle 4 are supplementary, so we can write their sum equals 180 degrees. Then we can just solve for the measure of angle 4. We end up with the measure of angle 4 being equal to 140 degrees. Now we basically have everything we need to figure the other angles out, I think. Angle 1 is congruent to angle 4 by vertical angles, so the measure of 1 equals 140 degrees. Note, angle 1 also corresponds to angle 5, as well as an alternate exterior angle to angle 8. So angle 1 is congruent to angle 5, which means the measure of 5 is 140 degrees. Angle 5 is also congruent to angle 4 since they are alternate interior angles as well. The only remaining angles we need are the measure of angle 6 and the measure of angle 8, I think. Measure of angle 6 is vertical to the measure of angle 7 and corresponds to the measure of angle 2, which means the measure of angle 6 is 40 degrees. The measure of angle 8 is congruent to the measure of angle 5 by vertical angles, so the measure of 8 is 140 degrees. We are also given that the measure of angle 7 was 40 degrees. Another example. We are told that angle 4 is 3 times angle 3. To find angle 3, we first should note that the measure of angle 3 and the measure of angle 4 are supplementary. A quick note, the lines L1 and L2 are parallel. Now, let's write the equation we were given. The measure of angle 4 is equal to 3 times the measure of angle 3. Now we can substitute that into the equation above, where we wrote the sum of angle 3 and angle 4 equals 180. Now we have an equation with just the measure of angle 3, so we can isolate it with some algebra. We end up with the measure of angle 3 being equal to 45 degrees. Another example. Here we want to solve for x. We have vertical angles, so we can set the two expressions equal to each other. Now we solve for x with a bit of algebra. and we get that x is equal to 9. Another example. We have two parallel lines cut by a transversal. Since L1 and L2 are parallel, we know alternate interior angles are congruent. So we set the two expressions equal to each other. Now we have a quadratic equation that we can solve by factoring or using the quadratic formula. Either way, we get the equation in standard form. Looks like we may be able to factor, but we need to do it by grouping. To do this, we look at factors of the constant term and leading coefficient, negative 40 times 3, so negative 120, that add up to the middle term's coefficient, negative 26 in this case. Then we split those middle terms up as those factors of negative 120. One nice way to organize the options is to draw an X and put negative 120 above and negative 26 below, and the factors on the sides. The first one that comes to my mind for me is negative 12, but that doesn't add up to negative 26. How about 20 and negative 6? That doesn't add up to negative 26 either. I think I got it. Negative 30 and 4 multiply to negative 120 and add up to negative 26. Yay! Now we split up the middle terms, negative 26x, as the factors, negative 30x and 4x. Then we factor by grouping. From the first group, we factor 3x, and the second group, we factor 4 out. Then we can factor the x minus 10 term out. Then set x minus 10 equal to 0 and 3x plus 4 equal to 0. Now we solve each for x. We get x equals 4/3, or x equals 10. Both answers are valid since when we plug them in, we get positive results. Now we will do a couple of examples involving proving lines are parallel. In this example, we want to find the x that makes the two lines parallel. From the left side, we see that two lines are parallel if their corresponding angles are equal. Also, two lines are parallel if their consecutive interior angles are supplementary. So we write the sum of the two interior angles equal to 180 degrees. Simplify a bit. Subtract to isolate the variable term. Dividing both sides by 19 to get x by itself. We get x equals 9, which is the value that will make the two lines parallel. Next example. Here we have two corresponding angles that have variables. If corresponding angles are equal, lines are parallel. So set the angles equal and solve for x. We now have a quadratic equation which we can solve by factoring or using the quadratic formula. Factoring by looking at factors of negative 15 that add up to negative 2, we can solve for x on each of the factors. We end up with x equals 5 and x equals negative 3. Both answers are valid since they produce positive results.